What do you see when you imagine an avocado armchair? What about a hub that looks like a snail? What about the famous Hollywood sign replaced by the words, "How am I weird?" These images are generated by an AI model called DALL-E, released by OpenAI in January 2021. It is named after the artist Salvador Dali and the Pixar character Wall-E. And this image is something I imagined for our new card game, How Am I Weird? A game for the weird and wonderful. I put a link in the description. Have a look. DALL-E, like you, has a fantastic imagination. The word fantastic comes from the Greek word fantastikos, meaning to make visible. DALL-E takes text descriptions and generates images representing the description. The descriptions can be as specific as the exact same cat on the top as a sketch on the bottom, or one that requires world knowledge, for example, a photo of a phone from the 1920s. DALL-E understands shapes, colors, 3D perspectives, styles, and even visual reasoning. DALL-E is not the only AI model that's able to imagine. A few years ago, Google released Deep Dream that generates hallucinatory, dreamlike images. However, unlike DALL-E, Deep Dream does not have the ability to connect images with language. So how did DALL-E learn to imagine from language? It learned from associating human search queries with image results. Technically, it is a transformer language model with an architecture exactly like GPT-3, except that the training data are sequences of words followed by pixels instead of just words. During model training, DALL-E reads words like kitten and make an association with photos like these, and reads blue cupcake and make an association with photos like these. After seeing millions of pairs of search queries and images, it learns to visualize descriptions in images. But you might wonder, how can DALL-E imagine things that humans never searched? The learning of DALL-E goes beyond simple memorization. The model learns to extract concepts that can be combined and reshaped. Thanks to the depth in the neural network and the attention mechanism of transformer, different layers inside the network learns concepts at different levels, ranging from surface form features, for example, yellow, straight line, to more complete objects, for example, cats, dogs. In our example, by seeing millions of images of kittens, blue cupcakes, and other objects, the model learns concepts such as kitten, blue, and cupcake, and is able to combine them in new ways and to imagine, for instance, blue kittens. The ability to combine multiple concepts to form a new image is how we humans created all these mythical hybrids between ourselves and other animals: centaurs, griffins, minotaurs, and many more. Try imagining a half-horse, half-human holding a sword. Our frontal cortex activates these concepts and instructs the memory and vision parts of the brain to create little snippets of horse, human, sword, and holding. These little snippets then travel and meet to form a complete image like this one. In order for this synthesis to happen, the snippets must all meet at the same time. However, because they are located in different areas of the brain, they have to travel at different speeds in order to meet. The control of these speeds is done by myelin, the fat tissue that surrounds the neurons. Myelination is more active during childhood, which might explain why children are generally more creative than adults. Imagination sets us apart from animals. Humans are storytellers. We create mythical creatures, gods, giants, whole worlds that we have never seen, and we share these imagined worlds with each other. For example, Salvador Dali imagined clocks like melted cheese in his mind's eye, and we get to experience his imagination through his painting, The Persistence of Memory. And now we have created AI that has overtaken animals in terms of imagination, and will probably soon catch up with humans. I leave you with this question. What is the purpose of imagination? Of course, creating stories is fun, but does it help us understand the real world? In my opinion, imagination, playing with reality, helps us understand reality in a deeper way. Look at the bull study by Picasso. The bulls in the top left closely resemble reality, while those in the bottom right are much more imaginative and abstract. Yet we have no problem recognizing those lines as representing a bull. By playing with reality, Picasso grasps the few important shapes and drops all the less important details, like sifting gold from sand. The perspective shift we gain from imagining allows us to distinguish the essence from the surface, and new combinations enable us to make use of reality to better suit us. In the same way, I suspect that by learning to map language to images, DALL-E the model learns language better than if it only read language. In order to link words with pixels, DALL-E has to extract concepts on a level that is neither words nor pixels. This means DALL-E could achieve a representation of meaning that is closer to the core and not dependent on the surface forms. Whether that's true remains to be tested. But for now, enjoy your fantastic imagination. Stop being a grown-up for a while and let your inner child create weird and wonderful worlds.